Hello there, it's Luke, and in this tutorial we're going to be focusing on clotting factors, and specifically we're going to talk very briefly at the end of the tutorial about the activation of fibrinogen to fibrin. So without further ado, here we go. So the overwhelming majority of clotting factors are produced by the liver. So they're proteins that are produced by the liver, and they're released into the bloodstream. And they're released generally in their inactive form. And the reason for that is that many clotting factors are proteases, by which I mean they will act on other proteins to break them down. Now, in the specific example of coagulation, what actually happens is that a protease will act upon another protein, another factor, and, if you like, release the safety catch, so that the newly activated factor can then go and activate or interact with other proteins and begin to sort of break them down to their more useful versions. A bit of terminology for you: a inactive version of an enzyme or protease, for instance, is often referred to as a zymogen, or will end with the letters OGEN, ogen. So you have fibrinogen, for instance, that is the inactive form of fibrin. So we have our inactive factor here. We have another enzyme, another protease that acts upon the inactive version that's been released by the liver, and we end up with our active factor that can then go on and sort of interact with other proteins and with other parts of their sort of haemostasis that we're trying to do. Now, I'll draw your attention just very quickly to sort of, not nomenclature exactly, but when you will see sort of written down sort of lowercase a next to the clotting factors that are the active version of a given factor, and that's how it'll appear in your textbooks and whatever literature you're accessing. Often, and there are a few occasions where this occurs, it will take more than one enzyme or clotting factor to catalyze or activate a sort of third factor, if you like. So you have your enzyme that might be factor 8, and it might have a cofactor, factor 9, helping it to do its job, or you might have factor 5 and factor 10 working together, and they will combine to activate another factor. So that's a fairly frequent occurrence within the clotting cascade. This is an example, and it's the example of probably the main reaction that we're heading towards with our coagulation cascade. So the sort of common pathway part of the whole thing, if you like that terminology. So we have thrombin, which is the active form of an enzyme, and it's catalyzing fibrinogen, which is an inactive form that's been released by the liver, and in doing so, it takes away this sort of like a little lock away from this piece of fibrin protein here, to give us our active version of the protein fibrin. You can see it's removed that lock, and you can see that we've got that little A there to denote the fact that this is now an active factor. And what active fibrin will do is group together to form a fibrin strand. So it's a very brief tutorial, this one, but in this tutorial we've stated that the liver makes the majority of the clotting factors. They're released into the blood in their inactive form, so you haven't just got random clotting going off all over the place. They are activated at the site of tissue injury and set in motion a sort of cascade of one factor activating another one. So one enzyme protease activating another enzyme. And we've talked very briefly about one of the most significant parts of the clotting cascade, that common pathway where fibrinogen is turned into fibrin by thrombin. Thank you very much for listening.